Here's problem number 29. We're going to try to find the second derivative of y with respect to x. And of course, along the way, we'll also find dy dx. Alright, let's take the derivative of both sides with respect to x. The derivative of y squared is going to be 2y. Now we've got the chain rule, dy dx. Here we're going to do the derivative of x squared, which is 2x plus 2. Dividing both sides by 2y, we get dy dx is equal to 2x plus 2 over 2y, which cleans up to x plus 1 over y. Now, let's take the derivative with respect to x of both sides of that. Alright, the derivative with respect to x of dy dx is d2y dx squared. This is going to use the quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom. And that's all over the bottom squared. Let's see if we can do a little cleanup there. Y minus x plus 1, and then we'll replace this dy dx with what dy dx is equal to, which is x plus 1y, and this whole thing is over y squared. Cleaning that up, in finding a common denominator for the top, I'm going to end up with y squared over y minus x plus 1 squared over y, and then this whole thing, instead of dividing by y squared, I'll change that into a multiply by 1 over y squared. So I end up with y squared minus x plus 1 quantity squared all over y cubed. Check the answer. And that's what they've got too. But they do another simplification step. Now, how do they do that? Well, let's acknowledge again, if we go back to that first one, we get y squared is equal to x squared plus 2x. Now, this is a plus 1 away from being a perfect square. I'm going to make it a perfect square, and I'm going to add a 1 and subtract a 1 and get y squared is equal to x plus 1 squared minus 1, or that y squared is minus x plus 1 squared is equal to negative 1. So this whole thing can be rewritten as that, and if that's that, it's equal to negative 1, so I end up with negative 1 over y cubed, and that's 29.